All right, guys, we're jumping into our CFA over 3.1 to 3.4, and we'll start out with the name collection box here. So the first one, 6 and 75 thousandths. We're supposed to write this at least 3 different ways here. One thing we talk about is always writing it like you say it. So I say it 6 and 75 thousandths, so I can write it like a mixed number, 6 and 75 thousandths. All right, so those two are equivalent. Another way we talked about doing this, we could do this with expanded form. And this is the ones column. 6 in the ones column is 6. Plus, I have 0 tenths, so I don't have to write anything. 7 hundredths plus 7 hundredths is 0.07. Got to get the 7 out into the hundredths column. Plus 0.005, because that's worth 5 thousandths by itself. And if I combine all that, I have 6 and 75 thousandths. Another way we can do this, I've got this light in the middle here, so I'll start over on this side, but we could do every column and do it with its place value times what we're taking that column times. So for example, this is the ones column. I could do the 1 column times 6, because that's worth 6, plus, I don't have to do anything in the tenths column, but this hundredths column, I could say the 1/100th column, let's do it as a fraction, we could have done it as a decimal, but 1/100th column times 7, plus the 1,000th column times 5. So there's another way we could write that there, and that would make sense. And they have the same value. Another thing I like to do is just make this into an improper fraction. Now remember we learned, guys, if we have 6.075, for example, if I multiply that by 1,000 to make it a whole number, it becomes 6,075. So I could say 6,075, and if I want to make it a fraction improper, I know to get that back to 6.075, I need to divide by 1,000 to move it back 3 times to get it back there. So again, I can multiply it by 1,000, then divide by 1,000, and I get 6,075 thousandths. And if I do that, it comes up to 6.075. So again, several examples of ways you could do that. The next part, we're going to circle the numbers that are equivalent. See, this one's got 27 hundredths. This one's got 27 thousandths. Those aren't the same. This is 10 times smaller, so let's look over here. Ooh, I see 27 hundredths again, because I can take that 0 off, so I know I found 2 that are the same. And this is 27 10,000ths. Nothing in the it's definitely not 27 hundredths there, because we bumped them over smaller. And here again is 27 hundredths, because I can take those 2 zeros off. So there are actually 3 of them that are all 27 hundredths. Okay, so make sure again you're writing all these down for your study guide. I'll pause the video if you need to. And if you're at home, you can pause that video. I'll make sure we have all these things written before we look at the other ones. Down below here, the next part, we're supposed to find 3 numbers that come between these decimals. And we know we can always zoom in and find decimals between decimals. And the abstract way, without the number lines that we learned, is if we just start with 3.4 every time, and we can add to it, you're never going to get to 3.5. So if I start with 3.4, I can put whatever I want after that. So let's just keep it simple. Add 1/100th. So 3.41 is bigger than 3.4. 3.42 and 3.43. As long as this doesn't get to 3.5, we're good to go. Again, some people like to put 3.4999. I mean, that's fine if you wanted to put something like that. Again, there are infinite solutions here. Same thing here, but they all have to start with 3.56. So if I have 3.56, if I add 1,000th, that's still not as big as 0.57 because I never got to 0.57. Okay, so I can add whatever I want afterward as long as I start with 3.56. So let's just make it simple, 3.562 and 3.563. So there's 3 examples you could have that fall between there. Second part, we're going to work on some adding and subtracting here with decimals. Remember, we should always estimate to make sure our answers make sense. So I'll do a little rounding here. 3.2, that's about 3. 24, let's just say 20. We'll make it simple. 17, we'll say is close to 20. You know, I know my answer should be somewhere around 43. You can do some quick mental math there. To do it the traditional way, to get the real answer that we've been working on, we know we need to line those decimals up. So 3.2, and I like to line all the decimals to make sure I don't forget to do it. 24, though, would be 24.0. We can add zeros in there, and we got to get this 2 out to the tens column. And then 17.0 So if I add these up, I've got 2 tenths, 11, 14, carry my 1, and I get 44 and 2 tenths, which makes sense because it's close to 43. So if I did my math and adding right, I know I'm correct there because my answer makes sense. Same thing here with subtracting. When we're doing the subtracting though, remember if it's 11 minus 5.32, we can put the answer on either side. Some people get confused when it's over here. We don't go this way. It's always left to right. So really it's just about 11 minus 5. And I know that answer should be close to 6. So when I write this out, you guys are going to want to write 11.00 for 11. Take away 5.32. Some mistakes I often see is that people just drop the 3 and the 2 here. Remember, 0 minus 2 is negative 2. So we need to decompose units of higher value or borrow. Can't do that there, so I'll take 1 away there, which gives me 10. Take 1 away there, which gives me 10 of those. And now I can subtract. And I'm going to have to decompose one more time. And I end up with 5 and 68/100ths, which is close to 6. Again, so the answer makes sense. On this problem, make sure you get them written down, guys, all of these. And again, we'll pause the video if we need to. And if you're at home, pause it on your own. Make sure you get these written down. Again, all this stuff should sound familiar, just reviewing stuff we've done. All right, so let's look at the last couple on the back and review some multiplying here of decimals. All right, so the first one we've got, this way we can see it, 3.7 times 1.2. If I'm going to do some estimating, I would round this to basically 4 times 1. That's about 4. That's about 1. The answer should come up close to 4 when I'm done. So 3.7 times 1.2. And again, we line it up. We don't always have to have it lined up when you're multiplying. It just happened to be this way. We just line it up with the right side because we're going to move these to whole numbers anyway. We learned when we do these traditionally, it's easier if I make this 10 times bigger and make it 37. And make this 10 times bigger, times 12. But remember, if I moved it once here and once here, I moved that decimal twice and made it 100 times bigger. So in the answer, I'm going to have to make it 100 times smaller. Sometimes we forget to do that. All right, so the first thing doing it traditionally, we're just taking 37 times the 2. We're not even worried about the one here that it's worth 10, but we're not worried about that now. So 37 times 12, 2 times 7 is 14, carry my 1, and 2 times 3 is 6, plus 1 is 7. 37 twice is 74, so that makes sense. Again, I get rid of what I carried over there so you don't accidentally use it again. Some people like to cross this out, and that hopefully reminds you to put a 0 here because this is not a 1, this is a 10. So if I bump it over once, it's already 10 times bigger, so I start putting my answers right here. And now all I need to do is take 37 times 1. 7 times 1 is 7, 1 times 3 is 3. And if I add all those up, I get 444. Well, remember, I made it 100 times bigger to get it to this. So take that decimal that's the end at 444 and move it back twice, and you should get 4.44, which is close to 4, my estimate. So makes sense. And then the last one here, we're just supposed to estimate and not do the moving decimals because sometimes we can get tricked doing it that way. If there's extra zeros sometimes or things can be out of whack, make sure we estimate. So on this one, I know this is about 40 and this is about 300. So I would just think to myself, 300 times 40. And I like to use this hang method, reminding me to drop that 0, which means I already took it times 10. Now just take the 4 times everything. And I get 340 times is 12,000. So I know my answer should be close to 12,000. And to get it close to 12,000, I have to put the decimal right here because that would be 12,625.2. So I know the decimal needs to go between the 5 and the 2 because that gets me close to around 12,000, which makes sense. So make sure you have these all written down and use this as a study guide for the test when we have it.